Hello and welcome to my session. I hope everybody had a good lunch and is energized for the remaining sessions of the day. My name is Michael Szczech, and I've been building on the XRPL for several years now. And over the last year, I started to take a deeper focus into the core RippleD software. And today we're going to give a brief overview of the fundamental concepts that I believe are important before you even want to get started building within RippleD. So by a show of hands, how many developers do we have in the room? Developers, okay, great. Now, same developers, keep your hands up. How many of you have developed or are building a project on the XRPL? Okay. Now, how many of you have built a feature from within RippleD? You can notice that the hands start to dwindle the deeper we get into the core. And that's why I'm here to talk about it. So what is RippleD? RippleD is the core server software that makes the XRPL possible. It enables a collection of decentralized participants to form a peer-to-peer network and contains a collection of protocol definitions that enable them to communicate effectively. Each participant or node maintains a shared and identical state, which is essentially just a live and accurate view of the status of accounts, data, and various different settings on the network. It also includes rules for modifying this shared state by applying transaction instructions to its current state, and they're able to enforce those rules collectively and come to an agreement on the next state of the ledger through the consensus algorithm. The big picture here comprises of these four components. So there are many components within RippleD, but these are the ones I believe to be the most important. Networking layer enables our nodes to effectively discover and communicate with each other. The process our nodes, the ledger breakdown is actually the composition of it's going to be the portion where we discuss the composition of the shared state. The consensus algorithm is the process our nodes take to agree on a new shared state. And then we're going to talk about transaction processing and the steps that they take to modify that state. Okay, so RippleD implements an overlay network, which is an interconnected set of machines that are running some type of compatible software. An overlay network is just a network built on top of a network. RippleD enables the XRP Ledger to behave in a peer-to-peer form, and nodes are able to connect when they initialize RippleD. These connections can be made over public connections and private connections. So when you first start up RippleD, how does it find who to connect with? RippleD has a peer discovery algorithm known as the peer finder. And when you boot up RippleD, the first step it's going to take is check your configuration file to determine if you have any IPs configured. If you do set any fixed IPs, every time you boot your RippleD node, it'll attempt to maintain and establish a connection, even if your settings are configured to only have a certain number of connections. It'll always ignore that and always attempt to establish a connection with that peer. Next, it'll check if you had any previously connected peers. If you ran RippleD prior and you have connected to the network, it'll periodically store them in your node storage. Lastly, if it's your second to last, is if you have never connected to the network before, it'll connect using hard-coded public hubs, which are essentially a centralized server, which is used for establishing these initial peer connections. The probability of actually establishing a connection with a public hub is pretty low because their connection slots are usually fully filled up. But instead of just declining your connection, they'll respond with a set of peers to connect with. And lastly, we have the gossip protocol. Once you establish this connection, peers will share information with one another about their peer connections, as well as nodes who have made requests to connect with them. So how are these connections established? It begins by sending an outgoing TLS encrypted connection. And this is to ensure that the connections can't be tampered with or prevent eavesdropping. Next, once the TLS connection is established, we request to upgrade that connection into an XRPL 2.0 protocol, which is the standard for XRP Ledger communications. And lastly, I wanted to mention that each connection that's established has a fingerprinted session ID. And this is important because it enables you to ensure the integrity and authenticity of a connection and prevents man-in-the-middle attacks. So once we're actually connected, what type of data are we sharing? We're sharing transactions so that every node has an up-to-date view on the broadcasted transactions throughout the network. We request ledger data if you're storing history on your node. Then you can make requests to backfill that history if you don't have it already. This is also important when you first boot up your node because it needs to actually pull the first ledger the most current ledger that is validated so it knows the active state of the network. We share proposals and validations during the consensus process. And we also share peer information as we discussed in the gossip protocol. So what's in a ledger? A ledger is just a digital record which maintains the current state, global state, and the newly applied transactions to that state. In the context of distributed systems like the XRPL, it's the shared state that all the participants in the network have agreed upon during the consensus process. It's identified by its ledger index or its ledger hash, and I would say that it's broken down into 3 parts. The first one is the state data. This contains all of the active accounts, their balances, their settings. We also have order books and network settings and much more. The transaction set contains the newly applied transactions for that ledger. And the ledger header is basically connecting metadata to the ledger, and it contains information like the last ledger close time, the hash of the transaction set, and a timestamp, and much more. Ledgers are only created and verified during the consensus process, and on your node at any given time, they could exist in 3 different forms. Open. Open's the mutable and discardable. Open is a mutable and discardable ledger. It's basically the open workspace for your node. So as transactions are being broadcasted throughout the network, as your node is receiving them, it'll add them to its open ledger. Closed. Closed is essentially just a immutable position on which our RippleD validator, our RippleD node, believes to be the next validated ledger. Although a closed ledger can't be changed, they're discarded as soon as they are deemed to be old or invalid. And lastly, we have the validated ledger, which is a verified and immutable state of the ledger at a given point in time. You could have as many as you configure to hold, as much storage as you can hold ledgers you could store on your machine. So how do we achieve consensus, and how does the consensus algorithm work? Well, consensus is the backbone of the XRPL, and it is the process which enables us to process these transactions in a distributed manner without the need of a central party. Its importance in the XRPL is that it ensures the integrity and consistency of the ledger. But when we think about consensus, we think, why might we need it just for a distributed system? Well, in a centralized system, generating a new ledger for a set of transactions is easy because there's only one central authority that needs to verify them and process them and modify their state. But in a decentralized system, the participants need to resolve any disagreements in their transaction sets, the order in which they should be stored and processed, and the results of actually applying those transactions. So in the XRPL, consensus ensures that the network can process transactions and update the ledger without the need of a central authority. The algorithm is designed with 3 core principles. Correctness is first and foremost, and it means that only valid transactions should ever be processed, and invalid transactions should always be rejected. Agreement is the second principle, and this ensures that all participants in the network can reach a consensus on the state of a ledger and the order of the transactions. Lastly, we have forward progress, and this is essential to ensure continuous operation of the ledger, and it guarantees that the ledger can grow and continue to grow even in the presence of faulty or malicious actors. So what does this process look like? It's broken down into three main phases: the open, establish, and accept phases. And the primary goal is to agree on a transaction set and what time that ledger closes. So in the open phase, what's happening here? Our node is basically idle in the consensus phase, and it's waiting a certain period of time in order for transactions to be propagated through the network and build up in its open ledger. It's able to actually advance to the next phase based on these different criteria. If we are working on the incorrect open ledger, our node might have fallen out of sync or disconnected temporarily. It'll first make a request to receive that most updated ledger. The second is if transactions exist for a sufficient amount of time. I believe the hard-coded value is about 2 seconds. So if you have transactions in your open ledger for about 2 seconds, it'll start to close the ledger. Third is if there's no transactions present in a ledger and an additional amount of time greater than the ledger min close time has passed. And lastly, it's if 50% of the prior round peers have already decided to move on to the next phase. So next we have the establish phase. In this phase, upon entering this phase, our node will essentially create our closed ledger, apply the transactions that we had in our open ledger in a deterministic way so that every server, should they all have the same transactions, should apply them to this set in the same order. During this phase, once we create these transaction sets, we create these proposal IDs by taking the hash of the transaction set and sharing that with our different peers. We compare our proposals, we receive them, and if we receive a proposal with a different ID, we'll then make a request to that node to receive their transaction set in order to properly make the adjustments to our transaction set. So when we are starting to get discrepancies in our peer proposals and we have these discrepanary transaction sets, we'll start to tally all the transactions in there. If they appear in greater than 50% of the proposals, we'll begin to add those into our new transaction set. If they don't appear in 50% of the proposals, then we'll actually remove them from our transaction set. Eventually, this process continues and repeats until all the nodes in the network agree on the same transaction set and order, moving us into the accept phase. In this final phase, we take this finally agreed upon transaction set derived from the previous phases and interactions with our peers, and we apply it to the previously validated ledger in the same deterministic way that we applied it in the previous one. We process the transactions and update the global state accordingly. If any transactions fail during this time, it'll be moved to the end of the transaction set. We then update our ledger header with the appropriate metadata, such as the new ledger close time and the new ledger hash and other metadata. Then we'll calculate a new hash, and we will then compare this hash with our peers to ensure that we process those transactions and we came up with the same hash as the other peers. Next, we're going to talk about the life cycle of transactions. So transactions follow this life cycle. They're initialized by being created by a user. You're connecting to some client application. You're signing them with your private keys. And then you're eventually submitting that into a node that you control or a public node. Once that node receives it, it'll perform some initial checks known as the pre-flight and the pre-claim. In the pre-flight, we're doing any type of check that doesn't require state data, doesn't require any data from the current ledger. such as if the syntax and the format is correct, if the account declared in the transaction actually has the proper signature for that transaction, if they've applied a sufficient fee deemed by the network. And then the pre-claim is any check that requires the ledger's state data, such as checking if the transaction has the appropriate sequence number, or for example, if you're sending a payment to make sure that you have the funds, or if it creates any ledger objects, if it could satisfy the reserve requirement on the account. And then once we complete our initial checks, that node will then broadcast the transaction to its peers. It'll enter the consensus process. It'll eventually become validated and applied, and then we'll call the apply function of a transactor. And this will actually contain your logic for modifying the state in the ledger. And then once the state is applied, we have verifiable results because our transaction is complete. So up until a few days ago, there wasn't really any documentation on what it takes to create a new transaction. So I have a little quick reference here. When you want to create a new transaction, you're going to have to begin by adding and defining various different types. These are all done in the protocol directory. You'll begin by adding a transaction type enumeration, like a transaction ID, defining any type of JSON that you might need for that transaction. The ledger formats are any on-data objects, any ledger objects that need to be created as a result of this transaction. New field definitions, if you're introducing new fields in the transaction. And then you have to specify which ones are required and optional, any transaction flags. And it's best practice to also create a feature definition, which then you could use to amendment guard your transaction. And then you have to actually go and create a transactor. This is done in the app directory, TX implementation, and then you'll be able to see a bunch of different transactions. If you're building your first transaction, I would recommend you just take a look and start to study the other transactors that are in that directory. And you'll have to implement this pre-flight, pre-claim, and do apply, respectively. And then once your logic is complete, you could guard your transaction with your feature definition. Navigating the repository. Now I'm going to give you some tips for getting started that I wish I had when I started looking into RippleD a couple months ago. And so when you first open the repository, you're going to see this source directory that's going to have countless, endless amounts of files. RippleD right now is about 1 gigabyte of code, so it can get pretty overwhelming pretty fast. I just wanted to go over some of these directories so you have an idea of what's going on in there. Beast, Unity, Basics, JSON, Crypto. These are some utilities that have things like string utilities, IP address conversions, JSON serialization. Next, we'll move on to the protocol. Protocol is a very important repository directory as it has a lot of definitions on our actual protocol. As you saw when we were defining a transaction, most of the definitions that we needed to make were in this protocol directory. And then core conditions, all these are specific to RippleD. They're kind of like the core components of RippleD. And then I would say the most important directory is the app directory, as it pieces all of these parts together to create what we know as the XRPL. So some tips, I would recommend you start by establishing a foundation, a strong foundation, the core concept of the XRPL and how things work. There are some great resources on xrpl.org that go into great detail on a conceptual level. Also, within the source code, you'll find many README files that contain an in-depth concepts and information to help you further expand your knowledge. Start from the main entry. If this is your first time looking at RippleD, or any application for that matter, you want to see where the application actually begins. What is the process, how everything is being initialized, the order in which it's initialized, as all of these are very important to understand how RippleD becomes the XRPL. And lastly, build a new feature. Start small and try to create a new transaction type. Maybe build your own private network at home. Try changing the currency and the genesis mint of your own network. The only way that you're going to learn is by trying. And that concludes my presentation. I hope that you gain some foundational knowledge and you feel a little bit more comfortable when it comes to RippleD and understanding how the core components work. Thank you.